So we're going to be looking at the x and the y-intercept, which is where the line crosses the x-axis and the y-axis. So we've talked a little bit about the y-intercept previously because we know that slope-intercept form has the slope, which is your m, and the y-intercept is your b. We never really, I don't think, discussed why b is your y-intercept, like how that works. So the y-intercept is where your line crosses the y-axis, and anywhere on the y-axis, your x value is 0. So when your x value is 0, and you are solving for your y-intercept, no matter what, this term is going to go away because no matter what your slope is, slope times 0 will be 0. And so therefore, when your x value is 0, your y value is going to be your x-intercept. So when your x value is 0, your y value is your y-intercept. And that's why we can just look at an equation in slope-intercept form and say to ourselves that b is our y-intercept. And then our x-intercept we haven't spoken about very much, but it's going to become really important when you start doing quadratics and you're trying to find your roots. And while that may not mean anything to you right now, what's important is that you understand that an x-intercept is where the line or the graph crosses the x-axis. And anywhere on the x-axis, your y value is 0. So in this case, when you're solving for your x-intercept, you have to make y 0 and then solve for x. So y isn't going to be isolated like it will be for your y-intercept. You're actually going to have to solve for it. And you're going to see how to do that in slides going forward. But what you have to understand is for your y-intercept, your x is 0. And for your x-intercept, your y is 0. So here are two equations. One of them's in slope-intercept form and one's in standard form. If my only goal is to find the x and the y-axis intercepts, then I can just go ahead and, if I'm trying to find the y-intercept, make x 0, which will then leave me that my x-intercept is 6. So as coordinates, my y-intercept is 0, 6. Again, I could have just looked at my b because my equation's in slope-intercept form, and I could have said, oh, okay, so my b is 6. I can't do that for my x-intercept. My x-intercept, I actually have to go ahead and make y 0. And so in this case now, when y is 0, I have to isolate my x, which means I have to use my equation skills. And when I use my equation skills, I get that my x is -2, so the point is -2, 0. For standard form, the good news is when you're doing standard form, you don't have to change it into slope-intercept form in order to do your x and your y-intercept. What you could do instead is for your y-intercept, you make x 0. So then you're left with 4y equals 8, and so y equals 2. So in this case, my y-intercept is 0, 2. And then when I'm looking for my x-intercept, I'm going to do the same thing but make my x 0. And when I make my y 0, I get that 2x equals 8, and then x equals 4, so my x-intercept is 4, 0. So when you're finding your x and y-intercept, it's important to remember which values that you're going to go ahead and make 0. In this case, if I wanted to graph the line and I really didn't want to make my standard form into slope-intercept form, I could use my x-intercept and my y-intercept as 2 points because any 2 points determine a line. I wouldn't always recommend this, as if one of your intercepts is wrong, then your line is completely wrong. But it would work as one way to graph a line. So I'm going to do one more example for you, as x and y intercepts aren't always nice, pretty whole numbers. They can often be fractions, in which case it would be very difficult to graph, as we'd have to be very precise with where exactly our coordinates were. So for our y-intercept, again, you make x 0. When you make x 0, you're always going to end up with your y-intercept. So in slope-intercept form, that would be your b. So the point would be 0, -1. And for your x-intercept, I'm going to make y 0. And when I solve for x, I'm going to end up getting a fraction. So x is going to be 1/5. And so my x-intercept is going to be 1/5, 0. well, in this case, I probably wouldn't use my x and y intercepts to graph a line, especially because my equation's in slope-intercept form, and I would just use 0, -1 as my y-intercept and go up 5 and over 1. Again, you could if you really wanted to, but plotting 1/5 0 would not be precise enough, and so your line may be a little messed up. Now with standard form, again, to solve for my y-intercept, I make x 0. I don't necessarily have to make it into slope-intercept form, although if I chose to make it into slope-intercept form, I would get the same answers. I get -4y equals 12, so y equals -3, so my y-intercept would be 0 and -3. And my x-intercept, for my x-intercept, I'm going to make my y 0, so I get 3x minus 4 times 0 equals 12. So 3x equals 12 and x equals 4. So my x-intercept is 4, 0.